Good morning, folks, and welcome to a special edition of Strut for Dummies. This is the wiring segment, and I'm able to use my sample case once again to create my own version of a fully installed Strut system. And I'm going to share some of that with you today. Think it'll be of some value, particularly if you've got a contractor who's getting ready to install or a designer who needs a better idea of the true mechanics of the Strut system. Arrayed here on this back plate is a fully functional Strut installation. We have the Strut itself, in this case a 2.5-foot segment. I have an outlet box that contains both an ELV dimmer and a 0 to 10 volt dimmer. I have a CPU, central processing and central power unit. I have the junction that would be directly above the Strut itself and normally would be covered with a canopy plate. And I have it all interconnected, and we're going to look at each one of those interconnections independently. First and foremost, we have power feed for a Strut system. That power feed, in this instance, is a cord, but look at it as any kind of line voltage, 120 or 277, feeding the system itself. Most notably, that power feed is going directly to the CPU. It is not going to the Strut. Strut is a 48 volt, constant power, constant data channel. There is no interconnection between whatever our line source is and the Strut. The incoming line is only being utilized by the input side of the CPU power supply, in this case a Meanwell, and there are a variety of sizes of those power supplies, but that is the only connection that line voltage makes. Continuing the power conversation, the now translated from 120 or 277 to 48 volt output taps off the back of the power supply, is interconnected and shared with the brain that we'll talk about in a minute, but is then run via composite cable, and we'll talk about what that is in just a moment as well, to the junction above our Strut, whatever the Strut end feed may be. For purpose of the demonstration, I've created my own composite cable. We would hope that folks would be using what we have suggested within our documentation. But in any case, what we're talking about is a pair of 12 American wire gauge and a pair of 16 or 18 twisted shielded data wires that go from the CPU to wherever the drop to our Strut may be. At that point, you will have received cabling from WAC to make that drop. I believe we ship a 10-foot segment of power data combo that you then tap and feed the end of the Strut. Back to the front end of this installation, we have all of our control on the front side of the brain. These wires, in this case, are being tied to 0 to 10 volt thumb wheels. But all of those interconnections with any form of control, be it legacy type like the ELV dimmer you see here, which power for which has to be provided to the dimmer, and then the output from the dimmer, line voltage output, is landed on the brain And in the case of 0 to 10, you're simply utilizing our supply for the 0 to 10, and it's landed on the brain itself in one of the purple and gray inputs. As I pointed out, any and all interconnection of a control nature happens on the front end of the CPU. So any and all of that cabling has to be fed back to either a power room, or if the CPU is in the ceiling, to the CPU first. None of that makes its way to the strut. What heads to the strut for reinforcement is the power and data output from the CPU, and that's it. As you see here, not that challenging, but incredibly important that everyone understands that this is not legacy type of installation where we have power and or the data going directly to the using component, in this case the strut, but instead all of that kind of interconnection and control, all of that happens on the front end. Output from the brain and power supply is then harnessed, and that is what we send to the strut.